Hello everyone. In this lecture, we want to learn about the nature of roots of a quadratic equation. We have already learned about the discriminant. Discriminant is b squared minus 4ac, and you know what ABC are. If we have a quadratic equation in the form of ax squared plus bx plus c equals 0, ABC are the coefficients of different terms in the equation. So A, B, C are real numbers. We know that A cannot equal to 0. And B squared minus 4AC, which comes from those values, it's equal to D, known as discriminant of the quadratic equation. Now, discriminant is a number end of the day because A, B, C are real numbers. So the discriminant, when you evaluate that, you end up with either a positive number or 0 or a negative number. There is no fourth case scenario here. If it is a positive number, you calculate the discriminant of a quadratic equation. You plug in for A, you plug in for B, for C, and you evaluate B squared minus 4AC, and you end up with a positive number, let's say 15 or 17 or some positive number. Then the quadratic equation has two distinct real roots. So two distinct real roots. Okay, so one answer could be like x equals 5, the other one could be x equals -4. Two distinct real roots. This is what's going to happen. You don't need to solve the quadratic equation if you don't want to, but at least you would have an idea about the nature of the roots of the quadratic equation. But what if when you calculate d, you end up with 0, for example? In that case, the quadratic equation has one real root. Some people say two equal roots. Okay, two equal roots is the same as one real root, basically, because you end up with like x equals 5. There's only one root. Or you may say the first root is 5, the second is also 5. Doesn't matter, end of the day, you end up with one real root. But if the discriminant happens to be a negative number, after you calculate that, in that case, the quadratic equation has no real roots. Okay, so these are the three possible scenarios. Graphically speaking, in this case, when the discriminant is positive, you have a parabola which has two x-intercepts, basically, something like this. Say this is a parabola that intersects the x-axis at 2 points. Okay, so we have two distinct x-intercepts. Sometimes the parabola, mind you, could open downwards, something like this, all right? And we may end up with two x-intercepts again, all right? Depending on opening up, opening down, it doesn't matter. If it intersects the x-axis at two distinct x-intercepts, that is corresponding to the case where the discriminant is positive, graphically speaking. Now, in this case, when the discriminant is 0, the parabola is barely only touching the x-axis at one single point. It's like this. Okay, so we have only one point of intersection with the parabola and the x-axis. Mind you, the parabola could, of course, open downwards. That is another scenario, but still we have one real root. So that corresponds to the case where the discriminant happens to be 0. There is only one point of intersection between the parabola and the x-axis. And sometimes the parabola is way far from the x-axis. It doesn't even intersect the x-axis at all. It's completely above the x-axis. So when there is no point of intersection between the parabola and the x-axis, it means there is no x-intercepts, and as a result, there is no real roots for the corresponding quadratic equation. Mind you, again, the parabola could open downwards like this, and it may not even intersect the x-axis at all. So in this case, we say that the quadratic equation has no real roots, and the parabola, which is the graph of the quadratic relation, has no x-intercepts actually. So these are the three possible scenarios. Now there's an example here. Here we have a quadratic equation. The ABC values are 1, -1, and -42. So without solving, I repeat, without solving the quadratic equation, I just want to know if this equation will have any real roots at all or not, or if we are going to have real roots, are these two real roots equal or they're distinct, or what's going on in general. So I'm going to calculate b squared minus 4ac. It's going to be negative 1 squared minus 4ac. So let's do the math. We get 1 minus negative times negative is positive. So 4 times 42 is 168. Add them up, it's 169. So we see that we ended up with a positive answer. The discriminant is positive 169. So because it's a positive number, without even solving this quadratic equation, we can tell that this quadratic equation has two distinct real roots. For this exercise, A is 9, B is negative 12, and C is 4. Different ABC values this time for this quadratic equation. Procedure is the same. Discriminant formula does not change. B squared minus 4ac. So it's going to be negative 12 squared minus 4a is 9 and times c. So that will be 144 minus 144, which is actually 0 this time. It's interesting that we didn't get a positive answer for the discriminant this time. So the conclusion would be that this quadratic equation, even if you bother solving it using quadratic formula or any other method, end of the day you will end up with the answer of that is unique. That is, we have one real root for the quadratic equation. So in this case, ABC values are 2, negative 4, and negative 5. C is negative 5. And we do b squared, which is negative 4 squared minus 4ac. And that means 16 minus negative times negative is positive. So I believe here, let me see, we end up with we will end up with a positive answer. So let me change this. So I'm going to put this positive 5, okay? I changed the value of C to be positive 5, okay? So now this is positive. And now when I calculate b squared minus 4ac, I end up with 16, which is negative 4 all squared, and then minus 4 times 2 times 5. So that's minus actually 40, because 4 times 2 is 8, 5 times 8 is 40. So minus 40. The answer would be negative 24, which is less than 0. It's a negative number. So the discriminant of this quadratic equation is negative. Therefore, this quadratic equation will not have real roots. We don't need to bother solving it. You just state no real solutions or no real roots for this quadratic equation, and that is it. Graphically speaking, if you want to solve the quadratic equation by graphic method, you will end up with a parabola which opens upwards like this green one, and it doesn't even intersect the x-axis. So there's going to be no x-intercepts for you to identify, okay? So these are the three scenarios that we can make a judgment about the nature of the roots of a quadratic equation. Either the discriminant is positive or 0 or negative, and in these cases, we are going to have different scenarios. Thank you very much, and keep practicing till the next lecture. Thank you.